Hello everyone, this is Dr. Song. Welcome to my YouTube video. Today I'd like to show you the concrete example how you can take the steps for analyzing your hypothesis, and then according to your purpose, how you can choose the statistical analysis appropriately. So my course is constructed based on the three courses I had assisted. So these are the courses available in the University of Ottawa, and then I took some content from these courses. So now let's assume you want to proceed with the inferential statistics. Your data is already cleaned, and then your descriptive statistics are done. So now your data is ready for the inferential statistics. And then now you can see that there are different options. And then these options show that what purpose you have for your analysis. So if we want to know the relationship between the two variables, you have to take maybe correlation or chi-square. How they are different? When your variables, two variables, they are continuous variables, you will up to 4 correlation. And then if your data, the two variables, the data don't satisfy the assumptions, and then you will take the Spearman's rule, because that is a non-parametric test, which means they don't exige you to satisfy the assumptions. But if that assumptions are satisfied, you can proceed with the correlation if your two variables are continuous variable. And then if they are not continuous variable, they are the categorical variables, like nominal or ordinal variable, you can opt for the chi-square. So anyway, correlation or chi-square, either or the other, they are supposed to find a relationship between two variables. Now, if your intention is to compare the means of the two groups, you can opt for the independent test or dependent test. But you can see here two groups, they are independent, means that two groups are different groups. It's not the same group. In that case, when you compare the means of the two different groups, you will opt for the independent t-test. But if your assumptions are not met or your homogeneity is different, and then in this case, you will opt for the Mann-Whitney U, that is a non-parametric test, doesn't exist, your assumption met. And then compare the three or more groups. So if you don't have the two groups, is more than two groups, and then one independent variable that is more than two groups, and then you can choose the ANOVA, that is a parametric test, and then Kruskal-Wallis, that is a non-parametric test, is a different version of the ANOVA. And the ANCOVA is a bit different because that you have the covariate the variable as a continuous variable. That means that you will delete the effect of the one variable that affect the mean of the three groups. So this is more advanced the level of the analysis. So we will deal with that is later. But we can first consider that ANOVA parametric, and then Kruskal-Wallis is non-parametric. So be careful about these two analysis, because when you have the group, they is a more than two, you should proceed with the ANOVA. So for instance, two group means that is like dichotomous, like gender. So the men and the women, or the another can be like married and non-married. But it's more than two groups can be here, married, single, and then without marriage, but they live together. Or you can also choose that the different age groups also. It's 10, 20, and then 20, 30, 30, 40, something like that. You can group them in the 10 years the difference, and then that becomes the more than two groups. So in that case, you can proceed with the ANOVA. And then compare two paired observations. So this is a dependent test, and this is independent test. Why they are different? because these are the different groups, men and women. But this one, it's not. It's only the same group. They will repeat. They will repeat the what they had the test. So, for instance, that this will be very much used when the intervention of the one treatment before and after, different time. But the group is always the same people. It's not like two different groups. They are all is the same group, and then you will just test for before and after. So, for instance, that one medication and the one treatment that is used after how the people's symptom changes before and after. So that is a very good example of the dependent test. And then if your assumption is not met, and then reflection rank that is be used. This is the different version of the dependent test that is non-parametric. And then compare a sample with the population. So when you want to see that your sample is close to the population, and you can use the one sample t-test and or chi-square goodness fit. So these are showing your data and your data from the sample that is close to the population, because our objective is that to guess the result of the population with our sample. So our sample should be proper to proceed with the inferential statistics. So in that case you can do that. And then predicting an outcome, that is a linear regression, because there is a reason why you can predict the outcome, not only about knowing the by correlation the relationship. If you know the one variable is related to another, its relationship is significant, like a correlation, and then you can proceed with the simple linear regression to know exactly how much it will be. That is possible because you have the one equation. That is the your y. So the y means the result is a, and then the x plus b. So that equation, you can use that to obtain the result of the y. So steps in the testing a statistical hypothesis. So first, what you have to do very in the beginning, you have to set the null and an alternative hypothesis. So there is no relationship between the two, and then there is a relationship between the two. That can be here relationship, that hypothesis. And then also the null hypothesis can be there is no difference between the means, and then there is a significant difference between the means. So that can be here compare the means. So this one and then this one and then this one also. Okay, and then this is another thing. But linear regression, you can see that that is coming after confirming the correlation. When two variables are correlated, and then you can proceed with the linear regression. So, and then you will put the alpha level, normally p equal 0.05. That is the standard alpha level. And then you gather the data, okay? And then you will do the a lot of descriptive statistics here in this step. We already saw that before inferential statistics. You have to clean the data, obtain the frequency table, the means and mode and the median, and then also standard deviation if you need. And then also if that is a Likert scale variable, you have to obtain the total score of the your Likert scale, etc. So all of them, they are in the descriptive statistics. After gathering the data, you have to proceed with that. And then you choose the statistical test. That is about in this step. So which test you will opt for, you have to consider here. So that is a statistical test. And then you will compute the your software. It can be SPSS, but also it can be the stat clause. It can be also the R, I don't know, the name is with the R Studio. Yeah. So all these different type of the software you will use to compute the test. and based on the result, decide if you reject or fail to reject the null hypothesis. So when you reject your null hypothesis, it means that there is a significant relationship, significant mean difference. And then if you fail to reject the null hypothesis, means that there is no significant relationship or there is no significant mean differences. Summarize the findings and present them in a way readers understand. So that will be very important to report to your result in the values. And also you can make the like infographic to show that visually how your result show the analysis. So the maybe that is a more proper to the public to make them understand about your result and also to convince them how they will take the procedure after. So this is one example. The government wants to establish a new anti-bullying intervention to reduce the rate of bullying. As a pilot study, they implemented this intervention to one high school. They measured the rate of bullying at the baseline before the intervention, then one semester after, measured the rate of the bullying. So now immediately you can find that which inferential statistic you can use because it's the same people, it's the same people of the high school group, and then just they had that intervention of the anti-bullying. So you have to know if anti-bullying intervention is efficient or not before or after. So that is when you see the here in this list, it will be the compared to paired observation. That means that different time but the same group. You don't change the group. So here, null hypothesis. The null hypothesis was that there would be no difference in the rate of bullying after the high school receives the intervention. And then the alternative hypothesis will be there is a significant difference. Okay, and then the alternative, yeah, here. So there is a difference in the rate of bullying, specifically a decrease after the school intervention. So when you say that in the alternative hypothesis, not only in the significant difference, but you said the decrease, that becomes the directional hypothesis because you are saying that it will decrease. So in that case, your p-value can be in the half. Like a p, it should be less than point 0.025, not the 0.05, 0.025, because you said the directional is only the one side, it's not the two sides. In symbol before intervention, after intervention, okay? And then note that together, these two hypotheses exhaust all possibilities. Yeah, so less bullying, same bullying, and then more bullying. If it's the same bullying and the more bullying, we will fail to reject the null hypothesis. There will be no difference, and only the less bullying that is we chose that is a directional. So we will proceed with this. Run the study. So when you run the study and then you can see the p-value is less than 0.05, but it's a directional, I think it's better to say 0.025. So that should be the more exigent to pass. And then finally your result is the before 120, but it becomes 100. So the mean becomes much less. And then the standard deviation is almost the same. And now especially most important thing is your p-value. The p-value is equal point zero to zero, so this is less than 0.025. So your intervention was significant. That makes a significant difference. So even if your null hypothesis is a non-directional, yeah, but we made it directional. Your conclusion should still reflect the direction of the differences. Of course, you will see by the mean value that is increased or decreased. So that is anyway you can find the direction. And then here, remember to use the two decimal places except for p-value because this is based on the APA style. So you have to write all these are in the italicized, and then you should report the value with the two decimal points. Only p-value that takes the three decimal places. Okay. So this is one concrete example how you can proceed with the statistical inferential statistical analysis from the hypothesis until the end. Okay, so we will talk about the more advanced approaches next time. Thank you so much. Have a nice day.